So today's lesson is dimensional analysis. It's the beginning part of Unit 2, and it actually is going to end up being the bedrock or one of the more important concepts that you are going to learn throughout the course of the year. Not only will you use it from now until June in chemistry, you will also use it when you take physics next year, or AP chemistry or AP physics. You're just going to use it a lot. So the quicker you master this skill, the better. So dimensional analysis allows us to find a relationship between two measurable quantities, and as a result of that, we can then go ahead and convert between the two quantities and make a comparison in terms of what one value equals in terms of another value, and we'll talk about what that looks like in a second. You always want to start with the unit that you're given, and you always want to start with the value that you're given. I generally tend to tell the kids, or tell my students rather, to put those values over 1. So I usually take my starting information and I just put it over 1 because I'm going to make a fraction, and then I'm going to use some type of a conversion factor, which we'll talk about in a second. So this is going to be my final unit, and this is going to be my starting unit, and ideally my units will cancel out and I'll be left with the final unit, or the unit I'm trying to find. So we're going to go ahead and show you a couple of examples of this. It talks here about significant figures, and we haven't talked about that yet, but we will definitely talk about that in the future. So two very simple examples are of conversions and dimensional analysis are how many eggs are in a dozen. And it's really, really simple for us to do this one in our head. So we know, for example, that in 1 dozen, there are 12 eggs. So that's the conversion factor. So that's something that I'm going to refer to as the conversion factor, or relationship. And so we can pretty much just look at this and say, oh, 4 times 12, no big deal, that's 48. But in chemistry and in all of our science classes from now on, we have to show our work, even if it's very simple. So I'm going to go ahead and I'm going to take my 4 dozen, I'm going to put it over 1, and then I'm going to use my conversion factor right here, but I'm going to set it up in such a way that my dozen unit cancels out. So I'm going to put 1 dozen on the bottom, and then I'm going to put 12 eggs on the top. And in this case, I can see that the unit dozen cancels out mathematically, and I'm left with 4 times 12, which is 48 eggs. Another way to look at it was if I had something like A times B times C over A C, all I'm going to really do is simplify as I go across this fraction and be left with B. That's what I'm trying to get at here. So when I talk about units canceling out. Another quick example would be how many pairs contain 50 shoes. So I know that I have 50 shoes. No, I lied. I shouldn't have done that. I'm looking at the relationship between shoes, or between pairs and shoes. So we know from the shoe store that 2 shoes equals 1 pair. So when I go ahead and I set up my math problem to support this, I say that 50 shoes over 1. And then I'm going to set up my conversion factor for so my unit of shoes cancels out. So I'm going to put 2 shoes on the bottom, and I'm going to put 1 pair on the top. And so when I go ahead and I look at my problem, I'm going to cancel out what I can cancel out. So I'm going to cancel out the unit of shoes, and I'm going to take 50 divided by 2 in this case, and I'm going to be left with 25 pairs. Okay, so it's not too bad, and that's a really easy way to look at it. So here I am. So, oops. Now we're going to look at some conventional metric conversions using dimensional analysis. We're also going to look at the metric prefixes that you're going to have to memorize and know. So I generally would like to start, or usually start, with something that we call the base unit. And the base unit can be 1 meter, or 1 gram, or 1 liter, or 1 second. It can be a lot of other things, but those are the ones that are most common, at least for our class. Going up this staircase, I have the prefix deca, I have the prefix hecto, and I have the prefix kilo. Going down the staircase, I have the prefix deci, I have the prefix centi, and I have the prefix milli. Now, the base unit is usually, like I said before, it's 1 something. It's 1 meter, 1 gram, 1 liter, 1 second. The deca really means 10 base units. So 1 deca is equal to 10 base units. Hecto means 100 base units. And kilo means 1,000 base units. Oh boy, spelling is not awesome today. Units. Okay. Now going down this, the deci is a prefix that means 1/10 of a base unit. Centi means 1/100th of a base unit. And milli means 1/1000th of a base unit. So if I was to write a conversion factor, for example, between meters and millimeters, I know that milli means 1/1000th of a base unit, so if I have 1 meter, I really have equal, or it would be equal to 1,000 millimeters. And also on the other side, if I'm looking at the relationship between meters and kilometers, I know that because kilo means 1,000 base units, that 1 kilometer equals 1,000 meters. So your responsibility is to memorize these conversion factors. And there won't necessarily be a quiz on the actual conversion factors. There will be a quiz using dimensional analysis using the conversion factors, so you have to know them. And I'm going to go from the base unit, which is the meter, back to kilometer over here. So that's the thing that I'm comparing. And I can go directly from base to kilo. I don't have to go to deca, to hecto, and then to kilo. So I can go directly from base to kilo. I know that I'm comparing centi and milli, and we can do it in a couple of ways, but I'm going to do it taking centi to the base unit and then the base unit back to millimeters. Again, I'm going to go here. I'm going to start at centimeters. I'm going to start here at centimeters, and I want to get to kilometers. And the only way for me to get there is to travel through my base unit and then to the kilometers. So this tells me it's going to be a 2-step. So here are a couple of examples about how to go ahead and use dimensional analysis to with the metric prefixes. So I'm going to start with kilometer and convert to meters. So in this particular problem, I know that my given is 1,250 meters, and I always start by putting that over 1. And I'm going to go from meters to kilometers. So I'm going to hop back here for a second. So what I'm going to do is I'm going to look for my conversion factor. And since I know that kilo is a prefix and meter is the base, I'm going to be looking at the relationship between kilo and meters. Okay, so we know that kilo meant 1,000 base units, so that tells me that I have 1,000 meters is equal to 1 kilometer. That's my conversion factor. So now I'm going to set up my conversion factor so that my units cancel out. So I'm going to put 1,000 meters on the bottom, and I'm going to put 1 kilometer on the top. My units for meters cancel out, and when I multiply across and then eventually divide, I get a value of 1.250 kilometers. Okay, now another example. We're looking at millimeters compared to centimeters. There are a couple of different ways to do this one. I'm going to show you the way that I generally teach this one. So I'm going to go back and look at my conversion factors again. And so that means that I have to figure out what my relationships are. So I know that I need to know the relationship between let's see, millimeters and meters, and the relationship between centimeters and meters. So we know that milli was 1/1000th of a meter. So that means that if I have 1 meter, I have 1,000 millimeters. And centi means 1/100th of a meter. So if I have 1 meter, I have 100 centimeters. So when I go ahead and I do this particular problem, I'm going to set it up so it's going to take like 3 steps. So I'm going to take the 6.25 centimeters, put it over 1, and I'm going to go ahead and go from centimeters to the base unit, and the base unit back to millimeters. So I'm going to set this up so centimeters cancels out. So I'm going to take 100 centimeters, put it on the bottom, and I'm going to have 1 meter on the top. I'm then going to go from meters to millimeters. So I'm going to take my, let's see, my 1,000, nope, I lied, my 1 meter on the bottom, and my 1,000 millimeters on the top. And so going back and checking my units, centimeters cancels out, meters cancels out, and I'm going to take 6.25 divided by 100, hit enter, then multiply it by 1,000, and I should get an answer of 62.5 millimeters. Okay, step chart type problem. So, and then our last problem is going to have us convert from centimeters to kilometers. So I'm going to go back real quick and look at that. In this particular problem, I'm going to start by identifying my conversion factors, and I know that I have to find the relationship between, oops, that's not the right tool I want. I know that I need to have the relationship between centimeters centimeters and meters, and I need to know the relationship between kilometers and meters. So first of all, I know that that centi means 1/100th, so that tells me that in 1 meter I have 100 centimeters. Kilo means 1,000 base units, so that tells me that in 1 kilometer I have 1,000 meters. So when I go to set this problem up, I'm going to take my given information, which is 465 centimeters, put it over 1, and I'm going to convert it from centimeters to meters, just like we looked at the step on the step slide, and meters to kilometers. So I'm going to set this up where centimeters is on the bottom, and so I'm going to put my 100 centimeters on the bottom, and it's equal to 1 meter. And then I'm going to set this up where I'm going to have to cancel out meters, so I'm going to put my 1,000 meters on the bottom and my 1 kilometer on the top. Now I'm going to go back and check to make sure my units cancel out. So in this case, I have centimeters, meters, and kilometers. So when I go ahead and I plug this into the calculator, I'm going to take 465 centimeters divided by 100, hit enter, divided by 1,000, and I'm going to get 0.00465 kilometers. Okay, so tonight your homework is to do the dimensional analysis worksheet, which is the first page in your packet. It is the one that is pink, and it goes from 1 to 13. So again, your homework is worksheet number 1. It's 1 to 13, and it happens to be pink in your packet. Good luck.